Hello, pre-calculus students. We continue our discussion and our work with the law of sines today by looking at what's called an ambiguous case. And let's just start by solving this problem, and then we'll see where the ambiguity comes in. So we have a side here, A equals 6, B equals 7, and angle A is 30. So in the traditional way that we're accustomed to solving this, we set up the picture. So we'll call this angle A, that's 30. And the side that's opposite of that is 6. We'll call this angle B, and this side 7. And it really doesn't make a big difference whether I call this B or C. I'm just calling it that so my picture is upright, and it helps me to see a little bit better. Okay? And so under this picture, I have a nice triangle here with what looks to be acute angles. And I can begin solving this. But here's what's ambiguous about this, is that I can draw another picture. So I try to draw this as closely as I can, so 30 degrees, 7. And I can turn this side in here instead of stretching it outwards, and I have another triangle. So we'll call this A. I should really name this C, little c, and angle B. So you can see here that I actually have two triangles that fit this description, and they're both legitimate. There's no reason why one of them should be accepted and the other rejected. Okay, so I'm going to revise the way that I name these triangles. Instead, I'm going to call this B1. Okay, I'm going to call this B2, and label the C's in much the same way, C1 and C2. And then, so since they're both triangles that work, I'm going to set it up using the law of sines in pretty much the same way. So I'm going to set up this one, sine of 30 over 30 degrees over 6 is equal to sine of B1 over 7. And that means 7 times the sine of 30 is equal over 6 is equal to the sine of B1. So this gives me sine of 30 is just 1/2. So this gives me 7/12 is equal to the sine of B1. You move this up here. And then I'm going to solve the other angle pretty much the same. I haven't solved it through completely yet, but I have to take the sine inverse. But let me just solve this one. Sine of 30 over 6 is equal to sine of B2 over 7. And you can see that the setup of these two problems are identical, but the angles themselves can't be. They're clearly two very different triangles. They share some of the same characteristics. They have two sides and an angle in common, but they're clearly two different triangles, so they can't both be the same. Okay? So let me just carry this out here to its logical conclusion. So 7 sine of 30 degrees is equal to sine of B2. Sorry, this should be over 6. And I also get 7/12 equals sine of B2. And then I'm going to type that into a calculator. So this tells me that inverse sine of 7/12 is equal to B2, and that's approximately 35.7 degrees. And of course, if I do it the other side, inverse sine of 7/12 is equal to B1, which is also approximately 35.7 degrees. And clearly one of these is correct and one of them is not. And so we have to look at our picture, and it's important to draw the picture accurately in this case. And you can see from the two pictures that we've drawn, in the first picture, B1 is an acute angle. And in the second picture, B2 is an obtuse angle. So that means this number, 35.7, is only for B1, not for B2. So let me cross this out. Okay, so for B1, this is in fact 35.7 degrees. Okay, so that's part of our answer for the first triangle. So that leads us to the question, is the second triangle really useless? Is it even possible? And if it is, how can we actually solve this? Okay, so let me erase all this other stuff here, since that was kind of a dead end. Now, just picture with me, what if we take this triangle and we move it and we superimpose it on top of this one? We would have the same image, we would have the same picture. And this dotted line here represents this side. This would be 6. This angle in here would be B2. And you can see from this picture that the triangle on the right here is an isosceles triangle, which means that this angle in here is also 35.7 degrees. And it is supplementary to B2. And so from this, we can conclude that B1 and B2 are supplementary. They're related. It's really two different triangles, but they're intricately related through these two angles, B1 and B2. So therefore, we can say that B1 plus B2 is equal to 180 degrees. And that means that B2 is equal to 180 minus 35.7. And B2 then is approximately 144.3 degrees. So now we have an answer for both B1 and for B2. And now we can use both of these to solve the rest of our triangle. Okay, so let me just write these answers up here. So B2 is equal to 144.3. And I'm going to erase some of this stuff just to give myself enough room to answer the questions. I'm going to write over here B1 is approximately 35.7 degrees. Okay. So let me solve this triangle first. So I would like to solve for C1. So C1 is really 180 minus 30 plus 35.7. So C1 is approximately 114.3 degrees. Okay, let me box all of these answers here. And then little c1, so I can use the law of sine again. Sine of 30 over 6 is equal to sine of 114.3 degrees over little c1. That means c1 is equal to 6 times sine of 114.3 degrees, all of it divided by sine of 30 degrees. So c1, little c1, I should say, is approximately equal to 6 sine 114.3 divided by sine of 30. So it's about 10.9. So we can write, I'll write it over here. Little c1 is approximately equal to 10.9. And we also have to do a bit of a sanity check and make sure that the biggest sides and the biggest angles are opposite of each other. So C1 is 114. That's clearly the biggest angle. The side opposite of that, little c1, is 10.9, and that's bigger than the other sides. So it works. At least it's plausible. It's reasonable. Okay. Now let's go back. Let's go to the other triangle here and solve for C2 and for little c2. So this angle right here, C2, is then equal to 180 minus quantity 30 plus 144.3 144.3 degrees. And that means C2, it's approximate, I should really say, use the approximate symbol here because this number, 144.3, is already an approximation. So that comes out to 5.7 degrees. And then let me box this as well so that we know this is part of the answer. So now I can use the law of sine again. Sine of 30 over 6 is equal to sine of 5.7 degrees over little c2. This side right here. Little c2 is equal to, or I should say approximate once more because this is an approximate number, 6 times the sine of 5.7 degrees divided by sine of 30 degrees. So little c2 is approximately 1.1 or 1.2 units. Okay, and we have to do a sanity check here as well. You can see that little c2 is the smallest side by a lot, and because the angle opposite that is also the smallest angle by quite a bit. And so now let's take a complete look at the problem. Let me zoom out here. All right, the zoom's not working, but when we're given these pieces of information, A, B, and angle A, it turns out that there are two triangles that are possible here, and they're both equally legitimate. And the key idea is that the two ambiguous angles, B1 and B2, they are supplementary. So you can solve for one of them and then subtract that angle from 180 in order to get the other one.